Hi everyone, in this video we're going to be talking about Python generator objects. Python generators are convenient tools that save a lot of memory on your computer. So let's have a look. So you define a generator as you do a standard function in Python. So generator, we're going to call it that, whatever you want. We're going to supply a number, we're going to set an I variable as 1, and then we're going to say while I is less than or equal to the number we will supply it with. We want it to yield I, and then increment I by 1. So what this generator is going to do is when we first create it and assign a variable to it, you can imagine that the cursor will run through the code and stop at Y, just before Y, and then it will wait there, and it will wait there until we call the method called next on the generator, which will then cause the code to be executed all the way around this loop back to Y until we call next again, when it will do this again until the while condition is no longer met. So let's go and test this out. So I'm going to open a Python interpreter here. I'm going to just save that. I'm going to start Python. I'm going to import. From my generators module, which is just a py file, or generator module, import everything, which is just generator. I'm going to assign the variable x, or the identifier x, to my generator, and I'm going to supply 10. So now, I'm going to, in Python 2 especially, in Python 3 it's slightly different, but in principle it's the same. So on x, which is my generator object, on x, I'm going to apply next. Now that will, so I'm waiting here, just before the y, and now when I execute that command, it's going to execute the next bit of code after the y and take me all the way back to y again. So there it goes, it's yielded 1, and if I do it again and again and again, I get all the values until this condition is no longer true, and that is now, and it yields a stop iteration exception. So this is great because instead of having something like this, a range 10, which is a list object and has kind of the same iterative properties as a generator. The problem with this is that if that number instead of 10 is kind of 10,000, the memory being held or being used up in a computer is going to be much, much bigger, whereas for a generator it creates a number when you need it, and when you no longer need it, it's not going to take up any more room. So let's do one other example. Let's call a word generator. So instead of taking a number, it'll take a sentence. It's going to say, I'm going to create a list called S, which is my sentence split on the white spaces. So it's going to make a list of those words. I'm going to create a new variable called I, starting at 0. So while I is less than the length of my list S, which is my list of words, I'm going to yield I, and then I'm going to increment I by 1, just like last time. So if I now go back over to my interpreter, go back into Python so I can import all again. If I now say Z equals to word generator, and my sentence is now generators rock the show. If I now put my call the next method on Z. Oh no, what I've done there is a bit of muppet, and I have yielded I, but what I want to do is yield I want to use that as an index to my string. So I'm going to go out of this again, let's get back into this quickly, try and find my, okay, now I'll do Z equals generator, word generator, and I'm going to say don't make stupid errors live on air. Okay, so now if I do next, what I hope to see is don't. If I now do it again, I'm going through all of the words of the sentence, and finally you get the stop iteration. Okay, thanks everyone. I hope this has helped explain a bit about generators. It's really simple and can be very, very useful in your applications. Okay, look forward to some new videos, which I hope to get out soon. Thanks.